Welcome everyone to another episode of Dragon's Den. Today, as the Science Edition, we will look into novel discoveries in the science and technology industry. Next up, we have Eric and Parsa and their solution, Anti-CRISPR, to genome editing. With both students from McMaster, Eric is studying BDC and Parsa is studying life sciences. Dragons today are Sarah and Masha.
Welcome to Dragon's Den. Please start when you're ready.
Hello Dragons, my name is Parsa and this is Eric, and today we're going to be pitching you an idea that will reshape the world of genome editing.
So you may all have heard about CRISPR and how it's the innate or natural defense mechanism of bacteria against bacteriophages. This topic has been widely characterized and explained throughout the Demystifying Medicine YouTube channel.
Yeah, so CRISPR basically involves the use of an enzyme that cuts and edits the DNA.
Wow, that's very interesting. How does it work?
CRISPR involves the use of an enzyme to edit the DNA. After the bacteria is infected with the bacteriophage, part of the viral DNA is incorporated into the bacteria. During subsequent infection, the Cas9 complex gets recruited and cleaves the phage's DNA. This leads to the death of the virus. However, we are here today to introduce you to Anti-CRISPR, a natural group of proteins found in the immune system of bacteriophages that inhibit the normal activity of CRISPR-Cas9.
Long story short, anti-CRISPR is a group of proteins that can bind to the Cas9 enzyme, the CRISPR-Cas9 complex, or the guide RNA to interfere with the function of these critical components.
Interesting. What is the importance of this concept and why it should be implemented?
Although there are ethical concerns over CRISPR, there's little attention paid to its safety as well as recent advances that pushes this technology further into human use. Although the utility is well known for gene editing, it involves the specific targeting of certain tissues or cell types. And once CRISPR is introduced into the body, so delivered or activated, humans have little control over CRISPR technology. This can result in harmful mutations in unwanted areas. This motivated our search for anti-CRISPR. Here we show the results of our experiment. For the figure D, the x-axis shows the concentration of Cas9, a CRISPR component, that binds the guide RNA, whose proportion is on the y-axis. The black line indicates the trend when we did not have our anti-CRISPR, but when we introduced our anti-CRISPR protein, the blue line, the entire graph shifts to the right, as you can see. What does this mean? This shows that for the same amount of guide RNA to bind Cas9, more Cas9 had to be present to reach the same effect, in a sense the same y value. Similarly, figure E has the same x-axis, but the y-axis is the amount of DNA that the CRISPR complex binds. As you can see, that given a certain concentration or amount of Cas9 on the x-axis, the fraction of DNA bound is significantly lower. Both of these combined indicate that our anti-CRISPR is highly effective in stopping CRISPR from functioning.
Great work, guys. It feels like you really understand the concept well. I understand that there are some ethical issues that come to mind with CRISPR. Does this eliminate this problem, or does it pose similar issues as well?
The debate on gene therapy is nothing new, but it has regained a lot of attention since the discovery of CRISPR, which provides an easier and more effective and accurate way of editing the genome. Most bioethicists and researchers believe that gene therapy for reproductive reasons should not be attempted at this stage, but they also believe that research and studies should be conducted to study and find better and easier and safer ways of editing the genome. Anti-CRISPR is the first step towards making gene therapy safer.
Great. We'll partner on this deal and we'll go in for $2 million for 20%.
20%? I think 20%.
Yeah, okay, sure.
Yeah, he would like to accept your offer.
Well, that concludes our science edition of Dragon's Den. Tune in to next week to see if the dragons take over any more businesses.